Well, we are still in the early stages of lockdown, so why not make a video? We're going to do how to calculate the materials you need for, we're just going to do some samples here, but you could do the whole house just the same, you know, trying to establish what it's going to cost you to build something over here. There's two examples we're going to use are the outside perimeter of the septic tank, and this is one half of the dirty kitchen. There's a door off of both ends of the dirty kitchen, so it's a good separation point to pour slip form the wall over here so I can get my counter done. And then the other side we're going to put another counter because we already have forms. We use those forms 7 times is the plan so far. The concrete itself is a volume calculation. You're buying your house by cubic feet or cubic meters. Is so much sand per cubic meter, so much gravel per cubic meter. The bags of cement are a cubic foot, 40 pounds. So we're going to do concrete and rebar and sand and gravel. Okay. Because we're using a computer on this, we can get our length times width times thickness with a single click. But in the normal run of things, you need to know how long your pour is, and how tall you're going to pour, and how thick the wall is. It's just simple volume. It's just not shaped like a cube or something. It's the shape of your house. So if you take the length of this long wall, the outside length of that, and you could pretend you were doing a wall that was sort of squared off on both ends. So you get this long one and the bottom long one, and then you take the short ones on the end, because you've already counted this corner when you did the long thing. So you need those 2 long numbers and these 2 vertical numbers. You add them all up, that's your total length. If you're using a computer, you can have the line around the outside, offset the line by half the thickness of the wall. Like if this wall is 7-inch thick, so we would just do the offset command at 3.5 inches, and then they ask the computer how long that line is. It's it's like cheating, but it's really all you need is the total length of the wall. And if you're doing a straight piece of wall, it's just whatever one side is. So in this one, we just analyze length. No, we don't have to do that even. Wait a minute. We do it even easier. Analyze mass properties, volume, and this whole box. And enter when we did that. And that's the number up here in the corner, 207, 224, 682. So either way, whether you multiply and you're added up all the lengths of the thing you want to pour, you know the thickness because you decided that yourself, and then how high your wall is. This wall is going to be 10 feet, but what I was doing here, this is the first lift that we're calculating, because we have some sand and gravel and cement. We're not completely out. I don't know if I can get any more for a good while because we're in lockdown, but rather than have the materials get filthy out in the yard, we're going to use them. Of course, we can't work anybody right now, but when we get free to work people to pour the cement, we're going to pour it. Okay, so this first lift is 207,225 cubic inches. We're going to divide that by 1,728. That's 12 inches times 12 inches times 12 inches. That's the cubic inches in a cubic foot. That's a sort of this is a standard you use. But all it is what 1 cubic foot is. We're going to divide the cubic inches, the whole piece of concrete is, 1,728, and we get 119.9 cubic feet. Now, experience over the last couple of years has showed us that our mix is 1, 2, 3. So if we take the 2 sand and 3 gravel, that's 5 cubic feet. The cement disappears into the mix when you put the cement and water in. So what you get is the 5 cubic feet of the aggregate, and the cement fills the spaces between the sand and the gravel, and the sand is filling spaces in the gravel. And we have like up to 6 millimeter pebbles in our sand. We buy that sand because it mixes the 2 sizes of aggregate and the sand, and it fills up all the spaces between the rock really well. It's probably a superior piece of cement or concrete. When I first saw it, I said, "Oh crap! Look how much junk is in there." But when you take it in a jar and mix what you're going to make your mix out of, and when you sort of roll it around with a little bit of water in it, you'll notice that those pebbles disappear into the gravel, and it just makes it stronger. So it's not really a bad thing. Anyway, so we figured out there's 119.9 cubic feet. We're going to divide that by 5, which is what a 1 bag mix is, and that tells me that it's 23.98 bags of cement, and we're going to call that 24. So times 2 would be 48, and times 3, oh golly, can't do that today for some reason.
On 44.
On 44. So you're gonna need that much cement, sand, and gravel for that 4-foot lift. And once you know what it takes for a 4-foot lift, then the 3.5 foot, you can just multiply by 3.5, divide by 4, and that'll tell you what those are. Let's see, we got another one down here. I'm going to do the cement on the second one before we do anything else. This is a half of a dirty kitchen. Also the full 4-foot lift. So analyze mass properties, volume, this, polysurface, and I'm gonna push enter. 128.699, that's like 0.7, so it's 123,129 cubic inches divided by the same 1728 gives you 71.25 cubic feet over 5 is 14.25 bags, times 2 would be 2850, 38, 42.75 on the gravel. And all these numbers, we always had when we're filling our bags, we're going to fill an extra 6 to 10 bags on a pour this size, and expect to find them still sitting on the ground when we pour it. And we can just pick those 6 or 7 bags up and carry them to the next place we're going to run the mixer. But you want to make sure you have 10% over in case you have calculation problems or the forms aren't the exact size. You're intending for a 7-inch wall, but it might be 7 3/16 or something. So make sure you have enough. At least the cement you need to have a little bit over. Okay, sand, gravel, cement. And that's pretty much all there is to that. On our living level, we had a tie beam in the ground. When we poured the columns, there's 20 columns in the house. when we got the second column poured, they were side by side. So we put the tie beam in between those, and that let us backfill that tie beam and do a lot of the backfill on the hole for the column up to the level of the tie beam. You can't backfill till you take the forms off, but the tie beam is up nearer the surface. The holes are 6 feet deep. And rather than having to get the dog out of there or kids or something, we just fill them as we go. One less thing to fall into. And the site looks such a mess when you start with these piles of dirt, and it looks like a landfill. And then as we went around, we kept doing them in order so we could keep putting tie beams. And then we went in, and while we were doing the outside ring of columns, we could take the mixer in and out any place we wanted, because the wall's 24 foot long, the mixer's 5 feet wide. So we get in to do the inner ring, and with that one you get to do the tie beam to the outer one and finish all that, and also backfill that. We call them spokes, but they're the tie beams, just because of the shape of the house. It made more sense to make everything sound like the parts of a motorcycle. Okay, so with this, the cubic feet, nothing more to it than that. It's just volume. You're buying the house by volume. If this was a fully cantilevered bunch of lanai decks stacked up with a core or some other things that continue it, it's all be counterbalanced to find the centroid of your chunk of concrete and make sure that that's sitting square over what you're going to support it with. You wouldn't need any exterior columns and supports and stuff. But being we have earthquakes here, we would put some kind of decorative columns just to, feel better about it, I guess. Earthquakes, when you see them in the news, it looks like everything is shaking side to side. It's not necessarily true. They're propagating like waves. If you shoved a piece of dirt, it doesn't come back. But if you take an ocean wave, as it rolls along, it's got an up and down along with the traveling forward. So you got to remember that when you're trying to design for this area. Okay, the next thing we're going to do is let's do the complicated one first. Yeah, we can do that. Okay. This one offset the outside shape to get the length of the all the walls. It was 617 inches. Okay, so a length of rebar is not 240 inches. It's not 20 feet in the Philippines. It's 19 feet 6 because it's meters. But I work in inches. So I could have used the actual length in centimeters, and I could just ask the computer to give me that number in centimeters. Or if I was working with a pencil and paper, I'd be adding up the long side outside and the short size inside. I'd get that same number. So we're going to find out how many rebars we're going to use. So we need to cover this length, and we're going to subtract off one rebar, another rebar off of that. But we don't get the full amount of the rebar length because we have to splice them together. So we're going to subtract off a splice length, and that's going to leave us a leftover of 181, and that's going to be made from another bar. And because it's going to be spliced onto these other two, it's going to need 2 more 16s, one for each end of the one over here someplace and one at the bottom someplace. So it's the 181 inches, 181 inches that we need more plus the 32 splices, and we divide that by 2 so this thing is symmetrical when we put it together. Makes it easier on the guys. We need 90.5 inches to the side. So we take a bar and we subtract off the amount we were short up here on this one. We took off the full bars. We ended up with, we were short 181 to get clear around it. So we're going to take a bar, subtract that off, and see what's left. Because we're going to use these drops. I'm going to plan on using them. They're already cut. Why not use them? Plus they're paid for. So we're going to end up with a 53-inch drop. And how many we're going to have left is 3 bars. These are vertical bars, by the way. And it's got this 53 inches left over after you've done all your lengths up there. No, these are the horizontal bars. Yeah, we're doing horizontal bars. That's why it didn't make sense for a second. Okay, so once we make a whole loop of a horizontal bar, we got 53 inches remaining. We're going to use them later. So it takes 1, 2, 3 bars. That's 3 bars. 2 we subtracted off whole bars, and then the ones that we got a piece from. So it's 3 bars for a lift times 6 bars in the lift. In 4 feet, we use 6 horizontal bars. 2 near the top, 2 near the bottom, 2 scattered in the middle. So 3 times 6 is 18 bars for the first 4-foot lift. 4 feet of lift. Okay, now the perimeter, that's why I was confused, is these numbers are the same. You got the perimeter, we're going to put the bars 9 inches on center. We happen to have a notch board 9 inches on center. But I'm not too lazy to put new notches on the other side of the board, or you can do a 3rd set of notches on the face of the board. You can't put it 4 sides, the board's too weak, it'll break. Because you're going to wrestle these things out from under the rebar. On walls, you just pick them up and carry them away, but on floors and stuff, you have to pull the wood out because you can't pick up that whole grid and carry it away. So we're going to divide the length of perimeter by the 9-inch centers to come up with 69 vertical bars. We're going to cut 35 bars in half. That'll give us 70 pieces. Let's see, 35 vertical bars. That's because 7. You have to. If you're making 69, you cut something in half. You got to have that the one that made the extra one. It's not even. It's not 68. It's 68 plus a half. So you have to cut a whole bar in half to get it. The 10-foot bars for the height of the dirty kitchen. So that's 35 bars, half of 70. Okay, obviously if you take a 10-foot bar, go from the floor right up to the top, you're going to need to cover that with horizontal bars. So this is figured the bars for the entire dirty kitchen. We had up here at the top 53 inches pieces, and it was how many bars was it? 18. So we got 18 pieces, 53 inches. Those are going to go under the windows because our first lift is 4 feet. And time I put a little bend on the end of these bars, like a 2 or 2.5 inch bend. That's for anchorage, so that you can't strip the rebar out of the concrete. That'll let us work with that 48 inch height. Plus, we want 2 inches of cover over top of the end of the bar, so that it doesn't have little round rust spots coming up to the surface. After that, the water doesn't penetrate the cement. The hydroscopic suction doesn't go any deeper than that. You get an old piece of concrete and you're cutting it with a stone saw or something. When you get down where you can cut something loose, the bar is still shiny inside. It's not rusty inside the concrete, but near the ends it is. Okay, so we have those bars, and we're going to take these. What was it? 18, 3 times, 1, 2, 3 times. Yeah, 18 bars are going to go across where the window openings are. We're putting 2 windows on each side that are kind of long, so we'll use off of these 18 pieces. We'll put them up right under the window. So we have 35 verticals. That's to get our stuff up here at the top, and 18 3 times 1, 2, 3 times 6 bars in 4 feet. 2 at the top, 2 at the bottom, 2 in the middle. So 6 times 3 is 18 horizontal bars. The second lift has another 18, and the third lift is not a full lift. It's not the full 10 feet, because the top of that bar has to stick out of the concrete to either pour another slab for the roof, like a 4-inch slab for the dirty kitchen roof, or if we're going to use a metal roof, don't know yet, then we have to have something we can bend over top of the angle irons and weld to them to basically attach all that to the concrete. So if we take the 35 and 18, and another 18, and another 12, comes up to 83 bars. This one is more typical of an exterior house wall, because we're accounting for windows and we would account for doors if we were doing doors. But it goes just like this. This could have more description in it, be clearer, but this is just the way that my notation is, because I can, this has been a couple weeks, but I can still sort through it and see what I was doing. Because I managed to put down the 32 was for splices, and the 2, when it says per side, I know I'm putting, the ends will be one, it'll be a bar with 2 bends in it going down, and then it'll be a straight section filling in. So we want to have the piece in the middle here that connects the 2 straight sections. Let's do a different one. If there's confusion on that one, it might not be on the next one. Oh, that first one was septic tank. No wonder. This is the dirty kitchen. Okay. There's a senior moment. You get this past 70, those happen sometimes. Okay, this one is, the wall is off, the outer wall is, either one, offset half the thickness, and that gives us a single line to measure the length of. And we divide that by the spacing of the bars. 5 foot. Okay. If you're cutting 5 foot on 3 bars, 5 fours are 20. So that's 12. 12 bars for verticals. The 29 must be 10 foot. 15. That would make, yeah, same thing. 15 cut in half would make 30, so it sure makes 29 with one piece left. So we have 3 bars cut into 5 foot. That's the verticals. And because some of the walls outside of the windows are going to go up to all the way, that takes 18. Okay, 12 bars for the first lift. Those are horizontal bars. Those are the ones that go around. So it takes 12 of those, and from that you're going to have drops 85 inches long, and they're going to apparently go on the corners up here that's not in the windows. Those are going to be horizontals on the second thing. So the total is 18 plus 12 is 30 bars for each half of the dirty kitchen, so to speak. 30 bars on this side, and the mirror image of it would be another 30. This chunk of concrete gets 60 bars in it. Apparently, this is with that spacing, with the 9-inch spacing between bars, we can use number 10. If we go maybe 12 or 12 and a half inches spacing, then with number 12 bars. But if you're trying to restrain cracks, more bars is better. You have a better chance of having steel at the crack. So that concludes the what we're doing here. We're buying the concrete by the cubic foot because the cement in the bag is in cubic feet. We calculated it in cubic feet. You could convert the cement, what a cubic foot of cement is, into cubic centimeters or cubic meters or whatever. Wouldn't be very many. It'd be awful small part of a cubic meter. The bouquets in the kitchen. They're all 3 named rows, and that's a bouquet to me. So you're buying the concrete by the cubic foot. If you know what mix ratio, if you're doing 1-2-4 or 1-3-2, we're doing 1-2-3 because we think that's the best bang for the buck. The cement's the expensive part. It's the one, and how much you put with it that to make the concrete, you can control that. But you know, if you keep adding sand, you're going to end up with hollow blocks. And the rebars, that's sort of a puzzle. You got to figure out what length of the wall it is, and how many vertical bars you need. That's like the space bar to bar, divided into the length tells you how many verticals you got. The horizontals, you figure out one band around whatever you're doing, and then multiply it by. For slip forms, it's generally 1 bar more on the 4-foot lift than on the 3-foot-6 lifts, but you count how many there are, and you're looking to find places where you've had a drop that's more than 30 inches long, and you find places to put them. And it's like a floor. If I was pouring a floor, and I have a column in here, and the floor is poured up to the column, well, that's going to give me an inside corner. They're unavoidable, but they're also a very bad thing. They're going to run a crack. You get a stress and concentration with the heating and cooling of the day, whatever, and that inside corner is going to run a crack, sort of perpendicular to the corner, if you know what I mean, like a 45-degree angle crack. It'll go down here, and then it'll turn the long ways of the slab. And you get them at all 4 corners. The way you get away from that is across the corner. Be 45 degrees to your up and down and left and right bars. You take these drops and you put the longest ones right next to the corner, right almost exposed, and then you put one or two shorter ones 3 inches behind it, and that reinforces that stress riser right on that corner, and that will keep it from cracking. And if you have all these pieces laying around over at your rebar cutter, like shear or chop saw, whichever you're using, or hacksaw, you know, but these houses can be built with a hacksaw. We have both other things available, but most times you see them using a hacksaw. Very good blades here. I think to put some in a suitcase and carry them to the States when I go. I can't buy this kind of good blades over there. I don't know what part of China they come from, but they sure do a good job on saw blades. Anyway, you go around your pile over there. When you get your grid tied for a floor, any place you got columns and stuff, you get those short pieces and put them in the floor. There's only so many you can use for stobs and everything else we use rebar for. So put them in your floor. You know, why have cracks when you can do something about it? Not so much around round pipes. Like if you have a 6-inch pipe for a well casing or something like that, you really don't get cracks on that. But small things, an internal, a 90 degree, around a post, and if the post is out in the middle, you'll get cracks from all four corners of it. So use up those shorts up there. It's doesn't take but a few seconds or a minute maybe to stick them down. They haven't got to be tied any more than what you'll dislodge them when you're walking around on them pouring concrete, because they're a couple inches off the ground, you know. Okay, you buy the concrete by volume. You figure out the bars, figure out the drops, reconsume the drops that are over 30 inches. You're going to lose 16 inches of it to the splice, but that's another thing. We run our bars, a lot of things, instead of going straight across and straight down the length, we run them at a 45. If I put a bar here, start off with a full bar, and I cut off 90% of the bar, that is the beginning of the next bar, and there'll be a piece left. It may go up here in this corner. But as you go across here, your splices on your bars don't match up, because you're taking constantly changing lengths off the end and make them the start for the next bar. The number of splices goes up this slightly, not much, and then you do the other ones going this way, and what you end up with is any place you're near an edge or where you're running over top. Like if this was just like one room and this was an interior wall, and you're running all the only ones that cross that wall to hold it together are the what would be vertical in this little drawing here. Whereas if you run over 45, both the bars run across that over that wall. So the wall is where the support is. You know, that's what's holding it all up. So the more bars you get running across that, tying the two halves together, or if you're if like we have upper tie beams that are 14 inches wide, so we have 14 inches of floor, 14 inches of width there. 7 inches of it can be for a floor going this way, and we can do a second pour from there over. We don't want to pour an entire slab over a day and a half. We can break it down into less than 80 bags a day. If you start early enough, it's still daylight to get it finished at 80 bags or 1 bag mixer. We got to hustle. It's that's about 84 is about our outer limit on where we figure another way to do it if it goes over that. If he hits 96 or something like that, that's not doable in a day. Even pre-staged materials to keep from working your workers half to death on the pour day, it's still that's just about as far as you're going to get. So but if you're going across this wall and you want to have a break in your concrete across there, that gives you twice as many bars across the break. If you don't want to run them a 45, what you do is you take your little drops you got everywhere, and you put them between the ones that actually do cross it, and just make sure you got 16 or 18 inches into each slab, both ends, and put a little 90-degree bend on the ends of them, and that works too. It's probably neater, but my wife watches them when they putting the rebars down, and she's pointing and talking to Galilog, and everybody's all hustling, and it doesn't take long to do it. It looks like a Chinese fire drill when they're doing it. But, everybody's walking someplace carrying a piece of bar or 2 bars or 3 bars and telling a guy to make 2 of this or 3 of that. But in a day, they're all down in tides. So it just looks like chaos. It probably really isn't. Okay, how do you do rebars? How much cost? That's about all there is to figuring it. We think the slip forms or poured concrete in regular forms like we did for full height, the labor's less. It takes longer to mix up enough bags of mix to fill the wall, so you have to keep that in mind. But the alternative is several guys putting up blocks, usually 1 block layer and 2 guys mixing, and another 2 guys carrying stuff to mix. Of course, you'd have that no matter what you were doing. But where the savings is the render is 4 parts sand, 1 part cement, and the concrete is instead of 1 to 4, it's 1 to 5. It's 2 sand, 3 rock. So your cement goes down because you're putting all your cement in render and filling cores of block, and you don't have that with poured concrete. And you haven't got to spend the time it takes to get all that render on the wall. And that takes a fair number of people and a long time. It's painfully slow. And then once you get that, everything's the same. If you have tie beams and under the ground and over the top and all that, you're still going to have tie beams. If you're doing poured concrete, it may only be the same width of the wall, because the whole thing is a column or the whole thing is a beam. You don't have any stress concentrations all carried back to corner posts, because the whole thing is poured concrete, just like the post would have been. And the rebars that would have gone into the post get spread through the wall, and the verticals are 1 piece from the bottom to the top, rather than about 3 or 4 pieces spliced with a lot less than 16-inch splice overlap. The best splice overlap you're going to get is probably about 10 inches. Whatever little bit is sticking up that doesn't make it out the top of the next course of block, then they stick a vertical in and it goes up another like 3 courses. So if you add up the actual bars consumed, every other block hole, and every 3rd horizontal row gets a bar end to end, you haven't got as much grid coverage in the wall as you do with the poured concrete. But where we pick up is we don't have to have the bars in the columns or in a top beam. It's all 1 monolithic pour of concrete, and a lot of those have a bigger diameter bar in the corners, and on the bottom of the beam will have a bigger bar where it's in tension. And the amount of steel in the wall is just a wash. It just depends on what kind of grid spacing you put on your poured concrete, whether it takes a couple bars more, a couple bars left. The bars are easy to tie, laying on the ground on, like the last videos called notched boards. We can put together walls so fast it's scary. You wonder how you're going to pay for that much rebar if you did it every day. Okay. Anyway, it's fairly inexpensive way as such things go. And this will tell you if you have enough rock, sand, and cement on hand before you get in the middle of pouring something. Floors are done like walls. You know, the rebar is easier to calculate, but the cement, sand, and gravel is a simple volume. How thick's your floor and what's the area, and that gives you the volume. And divide it by 1728, and that gets cubic feet. Divide it by 5, that's the bags. It's fairly simple. And any kind of house has that. Okay, if you learned anything from this, and I know this is a confusing video, just remember volume and figure out how not to have a lot of drops in your rebar. But if you learned anything, you can give us a thumbs up. If you say, I wish you'd never brought that thing up, you can give us a thumbs down. We're not monetary, won't hurt us. You can thumbs down all you want. And y'all have a nice day. Bye.